Okay, so today we're going to talk about the chi-square goodness of fit test. The chi-square goodness of fit test is actually easier than the chi-square test of independence. For starters, you really are only looking at one, basically one category instead of two categories in the test of independence. So a chi-square goodness of fit test is going to determine whether or not the distribution of one categorical variable in a sample fits a claimed distribution in the population. Today, we're going to work with M&Ms. According to the manufacturer of M&M's candy, the color distribution for plain chocolate candies is 13% brown, 13% red, 14% yellow, etc. Okay, so do M&Ms in our sample, that means the bag of M&Ms that you brought with you, suggest that the color distribution is different. So we're trying to say this company is claiming this to be true. How well does our sample fit with that? And obviously, we're only going to be doing one sample. But if you actually were doing this correctly, you would want to get many samples. So if I were to take all 130 students' results, then we can talk about what we got when we did this 130 times with 130 bags of M&Ms. Also here, you're going to find other examples of possible things that you can do, that you can use chi-square goodness of fit for. So the null hypothesis, just like before, states that the distribution for each category in the population is exactly the same as what is claimed. Okay, so the alternative hypothesis is that it is different. So here you see that we have stated the null hypothesis. The null hypothesis is that the color distribution for plain M&Ms is exactly as it is said in the company. It is 13% brown, 13% red, 14% yellow. So it's exactly the same. The alternative hypothesis is that the distribution of the plain M&Ms is different from that stated in the null hypothesis. So you are going to be testing this with your own bag of M&Ms. Take out a sheet of paper, a plain, clean sheet of paper, so that you can put your M&Ms on the clean sheet of paper. Clear your dust so that you don't have a lot of stuff on it. All you're going to be doing right now at the beginning is opening up your bag very carefully. Please don't drop any M&Ms because it's going to mess up our count. And you're going to put them carefully on your piece of paper. Make it like a little plate, so that you have your M&Ms there. You're going to sort them by color, and then you have to count to figure out how many M&Ms you have in total in your bag. So go ahead and pause the video right here so that you can go ahead and open your bag, pour them onto your little paper, sort them by color, and add up the total amount. I'll wait. Remember to pause the video though. Okay, so by now you should have sorted your candy and you have a total. Let's say, pretend the total amount of candy in the bag is 100. Okay, let's say that it's 100. What we're going to do right now is figure out what would be our expected counts. So if in fact what they claim to be true is true, if in fact there are 13% of the M&Ms that are brown, I would take the 100 total pieces of candy I have in my bag. Yours will probably not be 100. So whatever your total is, 89, 67, 120, whatever. And you're going to multiply it by 13%, which is 0.13. And that means that I should expect there to be 13 brown M&Ms in my bag. Okay, you're going to do that for every single color. If I have a total of 100 in my bag, 100 times 13% to be red, I would expect 100 times 0.13. That's how many red I would expect. So on the table right here, once you multiply your total times each percentage, I want you to write down the number that you would expect to be brown and red according to your bag. Your answers will be different than everybody else's because you might have a different amount of M&Ms in your bag. Okay, so figure out your expected values. Go ahead and pause the video again so that you can do those calculations if you need to in the calculator. All you're doing is taking the total amount of M&Ms you have in the entire bag and multiplying it by the percentages the company has told you that is included of each color. Go ahead and pause the video and do that. Okay, once you have completed figuring out your expected values, you're going to fill in this chart. The observed is, in reality, in your bag, how many brown M&Ms do you have? How many red M&Ms do you have? How many yellow M&Ms? So these are observed because this is literally what you have right now on your paper on your desk. This is the amount of brown, amount of red, amount of yellow, amount of blue, orange, and green that you have in that particular bag. Then you're going to copy over the expected values. Okay, so copy over the expected values right here. And that's literally as difficult as it gets. We're still working with chi-square, so we're still going to be using exactly the same formula. And except that we're going to be doing this differently. We're not going to put this into a matrix into the calculator. We're going to go back to our stat list, and we're just going to put them into our lists. So once you've inputted these values on your paper, go ahead and take your calculator, go to stat, go to edit, go to list 1. In list 1, you're going to put your observed values. In list 2, you're going to put your expected values. Okay, so no matrix right now, because that's only for the chi-square test of independence, where you have 2 variables. Here's only 1 variable. You put the observed in list 1, the expected in list 2. Then you're going to go to stat. I have these directions coming up. You're going to go to stat. You're going to go to calculate. You're going to go to test. And instead of option C, this time you're going to go to option D, which is the goodness of fit. Now, we still have degrees of freedom. Degrees of freedom for this problem is actually easier than it was. Instead of doing rows -1 times columns -1, you're just doing the number of like categories -1. So in this case, there were 6 colors, 6 cells in your table. So 6 -1 is going to give you a degree of freedom of 5. Okay. So when you go to stat calc test, it's going to ask you, where did you put your observed? List 1. Where did you put your expected? List 2. And then it's going to tell you how many degrees of freedom. So you're going to write down 5 because there were 6 colors, and 6 -1 is 5. And then that's it. You're going to go ahead and press calculate, and it's going to give you a p-value. Remember from the previous video, the p-value is going to be compared to the significance level, which is usually 5%. So we're going to use 5%. So figure out based on your information if your p-value is less than or greater than 0.05. And then you're going to make the following conclusions depending on your p-value. So either you reject the null hypothesis, or you're going to fail to reject the null hypothesis, depending on what you got for your p-value compared to your significance level. And then right here, I want you to actually write down your conclusion. Can you do this the same way we did last time, chi-square calculated versus chi-square critical? Because the calculator will give you a chi-square calculated value, and the answer is absolutely. Okay, the critical value will still come from the same critical chart, because this all falls under the same umbrella of a chi-square distribution. So here you would still look for 5 degrees of freedom at 90 point under 0.95. Let me make this bigger because it's kind of hard to see. Okay. So here, my degrees of freedom are 5. You would go to 5, and then it's 5% significance level. So the calculated, sorry, the critical value is 11.070. So that is basically how you would get your critical value. The calculator comes from the calculator, and you'll still be able to get the same exact conclusion both ways, chi-square calculated versus critical. But today I want you to practice more the p-value, because that's the part that we just learned. Okay, so go through this, take your time, read it, work together. And then you have a few problems that I want you to practice doing exactly the same thing, which is figuring out whether or not you're going to accept the null hypothesis or reject the null hypothesis for the chi-square goodness of fit. I will see you next class. Take care and work together. Bye.